Hello, in this video, I'm going to briefly talk about the questions in the homework. The first question I want to talk about is this one. It says using the Python's hash lib library, find a meaningful English word whose ASCII encoding has the following SHA256 hexadecimal digest. And it says basically as a hint, use hashlib.sha word that encode ASCII and ignore the hex digest to get the hexadecimal digest of an ASCII encoding of a given word. So in order to find a meaningful word, you need to have a list of all words. I have posted a dictionary.txt, which is the list of all the meaningful words in English. Assuming you have that one and you have it in your Python project, and you have it available, you can open the actual file, read it, read all the lines, and then in each line, you're going to see one word. So basically, you can create a list of stripped words, and for every word in words, you can strip the new line out of the word, and you can drop the last letter by doing word colon -1. That's going to drop the last character of the word, which is the new line, because in the dictionary.txt, as you saw, every line belongs to one word, and there's a new line at the end. This operation is going to drop the last character. And after that, what you're going to do is you're going to use the target that is given, which is this pretty long 256 number in hexadecimal, and try to find out which meaningful word has this hash digest or this hash value. In order to do that, the best way is to loop over every single word in the strip words array. This one is going to made of, this strip words array is made of 90-some thousand meaningful words without a new line at their end. That's why I call it a strip word. And when you loop over every word in this list, try to find out if the target matches any of the words hash value calculated by this formula. The formula should be str, which means the string representation of hashlib.sha256 in parentheses word that encode ASCII and ignore .hex digest. And basically in this formula, hex digest returns the hex value. So you first calculate the SHA256 hash value, and then you convert it to hex and see if that's equal to the target. When you find a word whose hash is equal to the target, you return that as the result, and you submit your assignment this way. Another question that is tricky is question 3, which is asking you to write down a function, a Python function for decrypting a ciphertext that is generated by the following encryption algorithm. The symmetric encryption function we have, you can, the encryption function we have here basically gets a key, which is a 8-bit integer. It's going to be an integer from 0 to 255. And as you see, I have it here. It basically gets a message, breaks it into 4-character pieces or 4-character blocks. Then it's going to call the make block on every 4 characters. This make block is going to concatenate all the 4 characters into one 32-bit integer, because every character is 8-bit long. When you concatenate 8 bits, it gives you a 32-bit integer. And you don't need to be worried about this part. This is already done. You need to take care of the decryption. Decryption is the reverse operation. And basically, After it breaks the message into 4-character pieces or 4-character blocks, and it applies the make block on it to convert every 4-character into one 32-bit integer. It's going to basically create an extended key using the same key by repeating that key 4 times, because the key is 8-bit long. When you repeat that key 4 times in a line, you're going to get a 32-bit number. The way it repeats the same key 4 times is to first add the key by the key after it shifts at 8-bit to the left, and then adds it by the same key after it shifts at 16-bit, and adds it by the same key after it shifts at 24 bits. This way, it's going to create a 32-bit integer, which is made of 4 identical quarters, and each quarter would be equal to the key. And after extended key is created and the number is created, all it does, it converts the block, which is going to be the one of the blocks that we created before. It was an integer. It's going to convert the hexadecimal, converts the following to hexadecimal. The block exclusive OR, this caret sign is the exclusive OR with the extended key. So in other words, it XORs every block with the extended key. So basically we XOR 2 hexadecimal, 2 32-bit numbers, and then it's going to convert it to hexadecimal and then converts it to a string. When you convert hexadecimal to a string, there would be a 0x. This 2 colon is going to drop the 0x because we don't like the 0x. We know it's already x, so we don't want to keep the 0x, which emphasizes this is a hexadecimal. So we already know it, so we're going to leave that out of the encrypted part. And this is going to be the encrypted version of that block. Then we make sure that the length of the encrypted block is not less than 8 hexadecimal digits, because the encrypted block is the encryption of 32 bits, which means 8 hexadecimal digits. If the result of encryption is less than 8 digits, less than 8 hexadecimal digit, we're going to pad it with leading zeros to assure that the overall length would be the same. The overall length of the decrypted ciphertext is the same as the actual message blocks that we created in this for loop. So anyways, after it's checks whether or not the length is less than 8 or not, it's going to add leading zeros if the length is less than 8, and make all the encrypted pieces 8-digit long, 8 hexadecimal digit long. And at the end, every encrypted block is going to be added with the return value, and at the end, we're going to return the return value. The first part of this question says, implement the decrypt function for this encryption so that it gets a ciphertext and it returns the plain text as output. So basically, we need to create a function like this. The cipher is the first parameter, the key is the second parameter. This is an 8-bit number. This can be any string. What we're going to do is we're going to break the cipher into multiple 8-bit pieces or 8-bit blocks. You can also break it into 32-bit pieces, but because key is 8 bits, you don't need to break it into 32-bit pieces. You can just break it in the same size as the key, and basically exclusive OR the key with each piece. And this is going to give you the original value. You may say, how is it possible? Well, I'm just going to briefly mention, so you understand. If A exclusive OR B is equal to C, imagine this is the plain text, this is the key, and this is the ciphertext. then I can say B exclusive C is equal to A. And you can prove that because of the properties of exclusive OR. So because of this implication, I can say when I want to do the decryption, I do the same XOR that I did before. So for encryption, we do XOR. For decryption, we do XOR as well. So that's how that's the nature of exclusive OR. And that's pretty much it. After you do the exclusive OR for each piece, you exclusive the key with each piece, you get the result of exclusive OR, and append the result of exclusive OR with the return value. Return value is an empty string at the beginning, but as you go forward, you're going to build that return value gradually at the end. You're going to return the whole return value. Return value basically begins with an empty string, and you gradually decrypt every block and append it to the return value. At the end, you get the whole decrypted plain text. And that's the question. That's the answer to the question 3.A. For 3.B, the question says, if we know that the following ciphertext is the result of encrypting a single meaningful English word with some key, find the key and find the word. In this case, we have two unknown things. One is the key, one is the word itself. But there's nothing to be worried about. And then the ciphertext is given, right? So this is kind of a security attack that you should always be aware and avoid. The security attack basically does an exhaustive search on all the possible keys, because the key is pretty short. It's a very, very weak key, and therefore it's a very weak encryption algorithm. If you want to make it stronger, you gotta elongate the length of key and make it longer and longer. But 8-bit is pretty simple. I'll show you how to break it. Basically, you go where every key possible. So you go for key from 0 all the way to 255. For key in range 256, you gotta do the following. You say if decrypt of ciphertext and key. The decrypt is the same function we called there. We created there. I didn't create it, but I didn't show you the creation of it. But I just told you that what you need to do is these 3 steps should be followed. So if you call this function, if you correctly create that function, and then you call it on ciphertext and key for every key from 0 to 255, and see if the result is in the stripped words, which is the same list that I showed you. This is a list of all English words. You got to print the key followed by the decrypted ciphertext with the key, and that's going to generate the output. If you make the decrypt function correctly, this for loop is going to answer the question 3B. Hope you understand how to do the rest. Basically, you need to implement the decrypt function, and yeah, that's pretty much all you need to do for this question. For the first question, again, as I said, first part, you need to read the dictionary, and then you need to go over every word in the dictionary to see if the target matches any of the words. Hash value calculated by the following formula. The formula was given as well. All right. Have a good day.